All right, guys, this is our short unit on sequences and series. We're only going to take about 3 days on it. So what is a sequence? What is a series? Well, we start off with a sequence. A sequence is just a list of numbers in a particular order, okay? Usually it's going to follow some sort of pattern. So the Fibonacci sequence is the one right here. So that's just kind of an example where you take the previous two numbers to get the next one. So if you look at 1, 1, 2, 1 plus 1 equals 2, 1 plus 2 equals 3, and so on and so forth. An arithmetic sequence is a sequence where you're either adding or subtracting over and over and over again each time. So that's called a common difference for an arithmetic sequence. A geometric sequence, the difference is there, you're either going to be multiplying or you're going to be dividing, and we call that a common ratio. So you're looking at what is the common difference or what is the common ratio. What am I either adding or subtracting every time? What am I multiplying or dividing every time? So that's kind of what we're looking at for there. So one of the bigger number patterns around is what's called Pascal's triangle. And Pascal's triangle is built like this. Pascal's triangle starts with a triangle of ones, and then every row after that kind of alternates, and then you fill in by adding what's above it. So you start off with 1, 1 plus 1 equals 2, 1 on the end. The next row, 1, 1 plus 2 is 3, 2 plus 1 is 3, 1 at the end. And it kind of follows that pattern forever. I mean, it just kind of follows that pattern, and that comes into play a lot. In probability, and it comes into play a lot when we end up expanding a binomial. So just kind of keep that in mind, that you should recognize that and be able to kind of build that. So for the next 4 terms of the arithmetic sequence, so what am I doing over and over and over again? Well, I'm subtracting 6 each time. So that's going to be 37, that's going to be 31, this is going to be 25, this is going to be 19. So if I take a look here, the geometric sequence, what am I doing each time? Well, here I'm actually multiplying by 4 each time. So multiply by 4, multiply by 4, multiply by 4. So 48 times 4 is going to be 192. Next one's going to be 768. Next one's going to be 3072. Next one's going to be 12,288. So that's just going to be kind of a couple quick examples. So now, when you're given some information, you can figure out any term in the sequence. It's like first term, second term, third term, 35th term, whatever, by using this formula. All right, and here's kind of what it says. If I'm looking for the nth term, you know, it could be the 35th term or the 17th term, whatever. I take the first term, that is what this a sub 1 means, my first term, and then I'm going to take my common difference times n minus 1. So if I'm looking for the 17th term, n minus 1 is going to be 16. Okay, if I'm looking for the 35th term, n minus 1 is going to be 34. Now, that happens because what I end up doing is kind of putting into an equation what I'm doing on a sequence. So if I've just got a little sequence here, you know, just call it, you know, start with 3, we'll go add 4 each time, so that'll be 7, 11, 15, 19. Well, this is the 5th term. If all I did was take my first term and go plus 4, plus 4, plus 4, plus 4. So I took my common difference 4 times. 4 is 1 less than 5. That's why this works. I take my first term and I do my common difference 4 times. That's kind of where this stems from. So if I take a look here, first month to rent a construction crane, it costs $75,000. Everything after that is a general increase of $15,000 each month. So I'm adding $15,000 each month. So how much is it going to cost to rent it for 12 months, better known as a year? So what I'm looking for is 12. My first term would be 75,000. N minus 1 is going to be 11. and my common difference is going to be 15,000. So what I've got to do is kind of evaluate that, put that together. And a little help from a calculator tells me it's going to cost me $240,000 to rent that crane for a year. So write an equation for the nth term of the arithmetic sequence of 8, 17, 26, and 35. So what am I doing over and over and over again here? Well, I'm adding 9. So 9 is my common difference. My first term is going to be 8. So that's going to be the a sub 1 is 8. So if I'm looking for my equation, it's going to be 8 plus n minus 1 times whatever my common difference is, which is going to be 9. So that would be my equation for that nth term. Now, when I change it up and go geometric, what I end up doing, remember, geometric means I multiply or divide over and over and again. And we represent multiplying over and over and over again by using powers. So this is actually raised to an exponent. This is still my nth term. This is still my first term. This is now my common ratio, or what I'm multiplying by, over and over and over again. And this is the exponent of n minus 1. Okay, so that's actually a power. So find the eighth term of a geometric sequence for which a1 is -3 and r is -2. So I need the eighth term. So that means I'm looking for a sub 8. My first term is going to be -3. My common ratio is going to be -2. But I want to raise that to the 8 minus 1 power. So I want to raise that to the power of 7. So -2 raised to the 7th power is going to be -128 times -3. That's going to be positive 384. So the eighth term in that sequence is going to be 384. So write an equation for the nth term of the sequence 3, 12, 48, 192. So this should look familiar. We go plus 4, plus 4, plus, or not plus 4, sorry, times 4, times 4, times 4. So that's my common ratio. So if I'm looking for a generic equation, a to the n, my first term is 3. My common ratio is 4 raised to the n minus 1. You can put that in parentheses if that helps you keep it straight. So recursive formula, what we've talked about so far is called explicit. And it's called explicit because it takes you straight to your term that you want. This one is going to say, here's the first term, here's a rule, give me the next couple terms. So if I look at this one, the first 5 terms in a sequence where a1 is 4, and to get the next term, I do that. So here's what that says. N plus 1 and n. So if I let n equal 1, all right, so that means I'm going to say to get 1 plus 1 term, or my second term, I'm going to take 3 times a sub 1 minus 2. All right, well, I know what a1 is. That is because that tells me that right there. So 3 times 4 minus 2 is 10. So my second term is going to be 10. All right, so now to get if I let n equal 2, then that means to get the third term, I'm going to take 3 times the second term minus 2. So that's going to be 28. So I'm starting to follow this rule of whatever the previous number is, put it in there, multiply it by 3, subtract it by 2, and that should be what I get. So for the next term, it'll be 28 times 3 minus 2. That's going to be 82. Multiply that times 3 minus 2 is going to be 244. Okay, so that is kind of how you build it from the first term. The other one was called the explicit. So if you have any questions, that's all I got. Come talk to me and we'll figure this out. I know this is a little bit change of gears from what we've been talking about so far, but it is good to touch.